Hello, my name is Logan Anderson. I am a member of Group 2, and this is our Chapter 6 exercise. So, the first part of this exercise was to use our SAS data analytics software and run a simple linear regression of the exam CSV dataset with exam mark as the target and hours of revision as the predictor. And then we want to verify that we get the same results as this little table 6.9. We really care about this down in the bottom right hand corner. So we ran this analysis and we can see that our R squared value is the same rounded, and we have our numbers here that are the same. So we see that we have done it correctly. So then we move on, and it says that using our software or a statistical package of your choice, we're going to run a simple linear regression using the data set of advertising CSV and using radio advertising spent as the predictor and sales as the outcome. Then it asks us what's the regression equation, and if you spend $8,000 on radio advertising, what level of sales would you expect to achieve? Then it asks us, is radio a significant predictor, and what is the level of significance, and what is the adjusted R squared value, and how do we interpret it? Also, is the model significant? So we look here, and we see that our regression equation will use these data points from our estimates. I put them right here. We have our sales for our equation. Our sales equals 68.98 times the amount of expenditure on radio advertising plus our y-intercept of 289.97. So then we plug in our 8,000 here and see that our sales is 68.98 times 8,000 plus 289.97, or our projected sales would be $552,129.97. In looking back to see if radio is a significant predictor, we see that it is, as our p-value is less than 0.00001. Then we look and see our R squared value. Then we see what our adjusted R squared value is. Right here, we see that it is 0.3128. And what that means is that our model, as we currently have it set up, is able to explain 31.28% of the data using the inputs that we currently have. So then, finally, we were to use our data analytics to run a multiple linear regression with sales as the outcome and TV, radio, and press as the predictors to create a baseline model. Then we would add an interaction between the TV and the radio to this model and see what that changes from the baseline. So then we want to look and see what the regression equation for the new model is. And then we want to see if that interaction effect is significant. Then we want to look and see if our R squared value changed any. So we come here and we look at our multiple regression here with our press, radio, and TV as our input and our sales as our output. And we go to our parameter estimates tab to look to see what our equation should be. And here I have the equation set up, and it is that your sales will equal 32.65 times the expenditure on press plus 63.57 times your expenditure on the radio plus 4.18 times your expenditure on TV minus your 188.14 to get your y-intercept. So then we want to see here with the interaction if the interaction effect is significant, and we can see here that our p-value is actually 0.96, so we can definitively say that no, it is not significant, as it lies well above 0.05. It lies even above 0.01. Then we look here and see that our R squared value actually did not increase because of the fact that we're not able to use this interaction, as it is not significant, and therefore it does not help us to predict potential values. Thank you.